3.6 is the section that kind of culminates what we've done in this chapter with putting it all together. Now that we've looked at the original function, the first derivative, and the second derivative, we can kind of use all those parts together to be able to tell us the most about a curve and do something called curve sketch, which is to draw a sketch without the aid of any sort of technology. So I'm just going to take you through some characteristics of curves that you have learned, not necessarily in this class, but kind of looking back like a history of what you've learned about curves over the last few years combined with what you've now learned this year. So, looking at basic things of what you know, and a lot of these things are not asked on the AP test, but some early topics is you should know how to find x and y intercepts of a curve. X-intercept is when y is 0, y-intercept is when x is 0. You should be able to understand symmetry in a graph. We'll actually use that a lot more later in the class. But from an algebra standpoint, you should be able to identify symmetry over the y-axis, symmetry over the x-axis, which is not actually a function, and symmetry over the origin or rotational symmetry. You should also be comfortable with domain and range. This comes into play a little bit in calculus, not a lot, but you should understand that your domain are your x values. It's what we're allowed to plug in. That actually shows up a decent amount when we talk about asymptotes in different places with continuity. And then range are your y values, your outputs, basically looking from like low to high. Continuity issues is one of the first things that really is more of a calculus topic, even though it's discussed usually in prior classes. We have continuity issues when we have holes in a graph. We call those removable discontinuities. And we have continuity issues with asymptotes in a graph. We call those non-removable discontinuities. Then we really get into the calculus, these last few characteristics. We started at the beginning of this year talking about differentiability and when a function is not differentiable. And we had three situations that create a not differentiable point on a graph. And that is either having a sharp point, having any of the previous discontinuities we talked about, or having a vertical tangent line. And then we really get into the derivative process when we start looking at the first derivative. So increasing, decreasing, relative extrema, minimums and maximums, those all come from looking at the first derivative. We can establish when a first derivative is positive or negative, which tells us when a function is increasing and decreasing. And we can also establish critical values and what critical values create extrema. If my function goes from increasing to decreasing, we create a maximum. If I go from decreasing to increasing, we create a minimum. Concavity and points of inflection all come from the second derivative. So we're able to find the second derivative, determine when it has intervals that are positive or negative to determine if it is concave up versus concave down. And we can also tell if the second derivative switches signs from positive to negative or negative to positive, which creates this POI or point of inflection. And then finally, the last piece of all of this is what we did last section, which is now we can look at end behavior, which comes from horizontal asymptotes. Horizontal asymptotes are created by taking a limit going to either positive or negative infinity. We use the guidelines that we discussed, and we find if it has any horizontal asymptotes, if it has a square root, it has the potential of having more than one, having two horizontal asymptotes. If we put all of these pieces together, what we end up having is we have the ability to graph a function with, again, without using a graphing calculator, without using Desmos, and we can be a pretty good representation. Now, when we do this, I talk about connecting the dots or using tools. So we're going to go through and do a few where you have to find your minimums and maximums and points of inflection. And then we have to figure out how do we connect the dots. And to connect the dots, we have four options. We have a section that could be increasing and concave up, which is the first little piece. Think of these as like tools in your toolbox. Then we have increasing and concave down, decreasing and concave up, or decreasing and concave down. All of our knowledge used combined with these different ways to connect the dots and graphing types allows us to sketch a curve. And that's your basic overview.